Okay, how's it going? So this video I'll be taking a pause from the regularly scheduled content to talk a little bit about careers, the future job market, and math class. So I think this is really important for everyone to hear. The structure of this video here, I'm going to talk about sort of that first bullet point there, out with the old jobs, in with the new. So the basic takeaway here is that as technology has improved so rapidly over the last 20-ish years, um, automated technology and robotics have replaced a heck of a lot of jobs, right? So jobs that people used to do by hand are now done by robots or by computers, and everything. So many of these jobs are automated. Okay, so it's important to me that you understand coming away from this class how important it is to pay attention to these developments as they happen, because you don't want to be someone who winds up in a job that's being replaced by the latest technology. Okay. The second bullet point there is kind of the flip side of that, which is that some of you will be excited by the new opportunities that are out there now, right? So with new technology come new jobs, and these new jobs might capture your imagination, might be something you're interested in. So I want to talk about those a little bit too. And the second bullet point here, even if you don't want a career in math or a quantitative career, you really do need to be aware of how technology is affecting the job market, because this can determine things like how much money you make, how good you are at your job, right? Like how well you fit in at your company. You need to be aware of changes in technology to be better at your job. Okay. So I wanted to start with just a couple of examples of math jobs that I've worked on, that I've been paid to work on. And my point here is that these jobs exist only because computers can run algorithms and do computations very, very quickly. These jobs were possible. They wouldn't have been possible without them, or at least they wouldn't have been as good. Okay, so this first one I want to talk about falls under the category of logistics, what's called logistics or operations resource. So I worked for a software company, and we would write artificial intelligent AI software. Um, and we got a contract from the Air Force. So one project I worked on was disaster response. So you can imagine if there's something like a big flood, right? If a huge flood happens somewhere in the US, then all of a sudden tons of supplies and materials and people need to get put into motion and sent to the right place, right? People are going to be needing help to get out of the flood. People are going to need food. We're gonna need to transport lots of people and supplies, and so it's a huge operation that has to be undertaken, and it has to happen very, very quickly, right? With a flood, the longer you wait, the more likely it is that bad things can happen to people, right? Houses are ruined, people lose their lives, etc. So you need to be able to act very quickly. You need to be able to coordinate amongst lots of different groups. You can imagine hospitals, food suppliers, the military. All these groups need to coordinate very quickly. So what I was working on was, you can imagine here's sort of a picture of a large network. Each of these blue dots might be some supply warehouse or some food, place that has food, a military base, and you can see airplanes are kind of flying through the network, or maybe there's other vehicles that are going through the network. So this is not the type of situation you want to sit down by hand and try to figure out, all right, Bill at, Bill's Grocers has 50 loaves of bread, and let's send them out to the people in need, right? It's something you want a computer to do very quickly to coordinate all this, right? And so that's what I was working on was can computers get really, really good at coming up with efficient responses by analyzing the network, right? This is what's called a network. Analyze the network and come up with a good plan. Okay, but disaster response isn't the only thing that is an example of logistics. Like any large company will have logistics and operation research teams. And these, you can imagine Amazon is an easy example. There are millions of people every day on Amazon who buy millions of goods. And all of those millions of goods and millions of people need to get, they expect to get their goods in a timely fashion, right? So you might have in the example in the picture, you might have warehouses that have the goods and then Amazon delivery vans that take the goods from the warehouses to people's houses, right? And it's not something that you want to plan by hand, right? There's no way that people by hand could plan out millions of deliveries of millions of goods, right? It just wouldn't be, if it was possible, it would be very slow compared to a computer that can run an algorithm very quickly. Okay, some other examples, FedEx and Google Maps. Here's a second example of something I worked on. This was, we had data from what's called an EEG machine, and that's just like this little cap you can see in this picture that a person puts on, and it's able to read the signals from your brain, these little voltage signals from your brain, and it makes a reading of those measurements. And the point was we needed to build a model, a model in the computer that would take in these readings and would try to get a good sense of what the person was thinking. So the input to the model was these readings from the EEG cap, and the output of the model was like, what were they thinking of? And the reason that we were doing this was an EEG cap is a non-invasive piece of technology, meaning you just put it on your head. So there are other technologies that can help people communicate, but they're more invasive. They might require a surgery or something. This is just a cap you put on your head. So if you imagine someone who has like a disability, someone who can't communicate, they might be trying to communicate, but for whatever reason they can't, right? This is where technology can help. So our job was to try to say, okay, well, if someone did have a disability and they're thinking something like, I want some water, for example, then you would want the machine to be able to pick up the signals from the cap and output, something close to what they're thinking. It's really, really hard. This problem is really, really hard because as opposed to someone who gets surgery and gets a much more sophisticated piece of technology put in, the cap can only read so much. So we were trying to read people's minds. We did okay. All right, but there's a lot of work in this field. And I didn't work on this project for too long. All right, and so one thing I'll just point out here from those examples, the functions you learn in high school math are the basis for the algorithms or for some of the analysis techniques that I used working on those jobs, which I think is pretty cool. It might be hard to see that now, but if you keep going with this stuff, you'll start to get a broader picture and appreciate it. Okay, and back returning to talking about careers, like those were some examples without computers to run those algorithms. You could not do those things even just 25 years ago. So when I was a kid, right? But now these are really high-paying jobs. So like the jobs that were around when your parents were your age or when I was your age in high school, they are not the same jobs anymore. Lots of jobs have disappeared and have been replaced by these jobs that I'm describing here. And now just to reiterate, even if you want nothing to do with a career in math, it's beneficial to understand how technology is changing the nature of work. And why is it beneficial? Well, for one reason, whether or not you work for a business or you work for the government or kind of wherever, you're going to find that typically you will make more money if you have skills that allow you to say analysis, quantitative skills. So even if you don't want to do a ton of math, you'll find that you'll make a little bit more money. You can make a little bit more money if you have some of these quantitative skills, right? So yeah, so let me give a quick example. So my wife works as a manager, and you might not think she's a financial manager. You might not think that managers need that much in the way of quantitative skills, but her understanding of technology and data analysis helps her do a much better job as a manager in terms of working with the organization she works with. She's able to be much more effective at her job by using technologies that other managers probably couldn't do. Okay, so just this little graphic here, don't lose your job to this guy. As I mentioned, so many jobs have disappeared due to automation. what are the sort of attributes that people have that machines don't? So what is it that you need to have so that you can at least protect yourself against being replaced by some machine? First thing, and I emphasize this in class a lot, people are creative and have intuition. Computers do not. Okay, your job is to be creative. The computer's job is to compute. Okay, so as we work in math class, we are trying to develop those problem-solving skills, those creative thinking habits, and this is important. People also can understand, interpret, and communicate, right? It's another part of math class that I like to emphasize. Can you explain your reasoning, right? If you can communicate, this helps a lot in jobs. People will find you much easier to work with if you're an effective communicator. Computers are not as effective at communicating ideas as people are. If you've ever talked with a chat bot and gotten very frustrated, you will know exactly what I'm talking about. Okay, and last I just wanted to list off some examples of jobs. So here are jobs that use both some math, maybe not a lot of math, but also people skills. Business managers, I mentioned an example a moment ago, right? The job is not just managing the people on the team, but it's understanding how the company is using technology, right? Whatever company you work for is going to want you as a manager to understand how they implement technology so that you can be more effective at managing your team, right? And understanding what the company's goals are. Entrepreneurs, you don't want to be someone who's starting a business today where technology tomorrow is going to crush your business, or where competitors, a competitive company, so if you're going to start a business and someone else is going to start a business, but they have much better technology, you're going to lose that fight, right? So it's important to have some awareness in what technologies are out there and how can you leverage them, etc. Okay, you don't want to be the person who's investing in this technology called a pager. You probably don't even know what this is, but you don't want a pager was like a cell phone that could only text, and it could only text like 6 words. It was like really crappy. It was in the 90s, and it was before cell phones. You don't want to be the person that's starting a pager company in the year 2002 or whenever the iPhone came out. Okay, you need to understand how technology is changing. Some other examples: political scientists, right? A budget analyst. These jobs are really about communicating with others your findings, taking in data and communicating that data, right? Political scientists are looking at trends in people's opinions. They're polling people and collecting data, and so on. Okay, but these jobs are really about communication as much as analyzing the data, right? People in general don't like to just talk in numbers. Like, you need to be able to interpret and communicate those numbers. Okay, and I've mentioned some of these newer jobs that use lots of math. AI research scientist. If you want to say work on self-driving cars, if that sounds something cool to you, then look up this career. Data scientists, statisticians, quantitative analysts, like all these jobs, whether you're working for a big company like a Google and you're analyzing trends in data, you're looking at sales data, or maybe you work for a bank and you're trying to make money in financial markets, right? All these jobs are going to require quantitative skills. Software engineer, maybe you like to play around on the computer a lot, make applications or software in computer code, and this is going to, this is a lot of fundamentally mathematical ideas, and many of which I try to get across in our class. Engineer, you want to build stuff, you need to have quantitative skills. Pretty straightforward there. Economists, just scientists. The whole nature of science has changed a little bit since computers. People are way more likely to build models from data now than they were in the past because it's so much easier using our technology. Even if you're a biologist or an ecologist or a chemist, it's like using the computer, collecting data is sort of the standard way things are done now. Lastly, I just want to point out you can be a research mathematician. This is not something that I ever realized in high school. It's something I spent 6 years as a graduate student doing and a couple more years after that. But you get to ask just really cool questions, what I think are really cool questions, and you get to be a part of a cool community of people who like to ask interesting questions, who like to solve problems. So I put an example here. What does a seven-dimensional sphere look like? You might think, what is he talking about? Like, we live in 3 dimensions, but like mathematics is cool in that if you want to just play around in seven-dimensional space, you can do it mathematically. You can come up with little models. So even, be creative and think about what that might mean. It's in the 1950s, there was a guy who actually quantified how many seven-dimensional spheres there are, which sounds pretty wild. But when I first heard that, I was like, that just sounds cool and trippy. So I think I'd like to learn more about it. Some of these other things I've put here, does AI really think? You can research how AI algorithms actually work and how to improve them. Learning secrets of the numbers and shapes of the universe, which is something that humans have been doing for thousands of years. Lastly, using creativity and intuition to solve problems. Okay. So in summary, and I've put some links here, even if you want nothing to do with math in your career, you should be aware of how the job market is changing. In particular, will your career pay less in the future due to automation, or will it disappear entirely? I like publications like Wired and the Wall Street Journal. They tend to write a lot about the intersection of technology and jobs. Analysis skills, quantitative skills tend to pay more if you want to do a little bit of math. If you want to do a lot of math, then there's all these cool, new, exciting careers that exist now that didn't used to. So anyway, thanks for listening.